Let's have a look at what happens when we break existing bonds and form new bonds during a chemical reaction. Remember that chemical bonds will form as a result of the forces of attraction between the atoms or ions in a compound, and during these reactions, existing bonds are broken and new bonds are formed. I want you to imagine this is like a love relationship. Currently, the blue molecule is in a relationship and the purple molecule is in a relationship. So we have got two blue dots connected and two purple dots connected. Now, when we break the existing bonds, it's like breaking up with someone. It's not you, it's me. I need to work on myself. I need to be a better one before I can be part of two. Oh, so exhausting. So breaking these existing bonds absorbs energy. When energy is absorbed, we know that it is an endothermic reaction. So we can say that to break bonds, the attractive forces between particles must be overcome, energy is absorbed, and it is endothermic. Now, when these bonds are broken, we know, of course, that now we have these blue dots that have been separated and the purple dots that have been separated. At this point, it's complicated, isn't it? If you've ever been in a relationship, broken up with someone, before you move on to the next one, maybe your Facebook status was, it's complicated. So when the atoms are in this phase, we say that it is called the activated complex. When new bonds are formed, energy is going to be released and it is exothermic. So now when one of these purple dots connects with one of these blue dots, we see that a new bond is formed. And when this new bond is formed, it's like a new relationship. And you know when you are in a new relationship, it's like you can live on love and water alone. You don't even need food. So a lot of energy is released. And when energy is released, we know that this is an exothermic reaction. So as you can see, during a chemical reaction, we have the breaking of existing bonds, which is endothermic, and the forming of new bonds, which is exothermic. So how do we determine the change in the energy here, or the enthalpy, or change in H? Remember that energy change is going to be the sum of the energy absorbed, breaking bonds, minus the sum of the energy released, forming new bonds. So if we look at this, let's say that the energy absorbed is larger than the energy released. It means that the change in H will be larger than 0 or have a plus value, and therefore overall is endothermic. If the energy absorbed is less than the energy released, we know that the product's energy is going to be larger than the reactant's energy, and therefore we can say that overall our change in H will be negative or smaller than 0, which means that the overall reaction is then going to be exothermic. It's important to know here that while we only have one chemical reaction, in the forward direction, we can determine whether overall it is going to be endothermic or exothermic.